All right, this is lecture 3. Sorry about that last lecture, cut off at 10 minutes for some reason, but we will continue right where we left off. I was just explaining when I was so rudely interrupted by whoever's in charge of this screencast-o-matic, cut me off at 10 minutes. But we were just saying, don't forget to put the mole amounts in the beginning when you're doing this setups. So those molar ratios, 2, 1, 2, 1, 2, 1, 2, 1. Okay, so I just peeked at the numbers for these. This one's going to be off. Actually, by quite a few. So don't worry about the fact that these numbers aren't exact. As a matter of fact, this is how I'm kind of checking to make sure that you're doing the actual numbers. You'll be in the right ballpark, and obviously a large negative value tells you that it's going to be thermodynamically favored. Okay, so that's really important. This number's off by a tad too. But just make sure they're close, and then use the numbers from your thermodynamic quantities attachment. One of the things, as we relate this to kinetics, if they're thermodynamically favored, they're not necessarily fast, and that has to do with the kinetics of it. It doesn't measure the reaction rate. An example, imagine how long it takes an iron beam to rust away. It could take a couple hundred years. But some of them are doing that, and we're having to repair a lot of bridges around. So kinetic control, if we read through this, thermodynamically favored processes that do not occur at measurable rates are said to be under kinetic control. And this would often be the result of a really high activation energy. It cannot be assumed that it has established equilibrium. Okay, so when that happens, so this is the one that I want you to circle, is this statement right here. If it is known that a certain process is thermodynamically favored, but it does not occur at a measurable rate, the process is most likely under kinetic control. Okay, and then external energy can drive reactions when delta G is greater than 0. So you have a non-favored process, you can just plug it in to a battery, and you can power it, and you can drive it uphill and make it favored. So this would be something that would not be favored, and then you can just get a power source to do that. The example that is very well known is that CO2 and H2O can be made into sugar. That's a really hard process to do, but if you put some energy into it, like sunshine, look at how unfavored that reaction is. Well, just imagine carbon dioxide and water having to get put together, and those of you who understand photosynthesis, you know that there's a very sophisticated set of reactions that allow this process to happen. Multiple steps, as they say here. All right. Okay. So, and it's the photons from the sun that create that energy. So you just need to plug in some extra energy. This is the initial step in the metabolic breakdown of glucose. I don't know how much you guys have written about this. Hit the pause if you need to, but I'm just going to continue talking in case they cut me off at 10 minutes again. So this is the conversion of ATP to ADP. And what that is an initial investment of energy is needed whenever you start this photosynthetic process. And you can see that is thermodynamically favored. You have these ATP molecules. They will be at a lower energy here and end up giving off energy to the system that can be utilized in this next step. And then you can couple the reactions. Okay? You can couple the two reactions where basically you're saying these HPO4 minus 2 groups will cancel out, the hydrogens will cancel out. You couple them, and basically you're saying, well, you take this sugar molecule and then you add ATP to it, and it makes sugar with a phosphate attached. It's called glucose 6-phosphate. And at that point, then it can further break up. But this process, you can see, okay, yeah, that's a thermodynamically favored process if you throw ATP in the mix. And those of you who know your energy really well from biology, you knew it was really all about making ATP and converting it to ADP and vice versa to manage that storage of energy on the chemical level in biochemistry. Okay, so that's the last topic here, and to prove that you watched until the very end, you're going to draw some little stick figures, about 2 or 3, doing different things, maybe jumping, or maybe one that's running, one standing on their head. 2 or 3 stick figures doing different activities. Okay, nothing R-rated, please. So happy stick figures drawn in right there to prove that you watched the video to the end. Happy Thursday, and that's all you need to do. And we'll do the same thing tomorrow. So some of you are getting nervous that this isn't enough work. Continue to look at those practice tests, and I will give you some more of those to do this weekend. And I also will give you like a practice test for this thermodynamic stuff at the end. Make sure that you have sharp skills in this area. Okay? So that's what you have to do for today. We learned what delta G is. Awesome! Bye.